So this is just a little demo for Kubeless. Kubeless is a serverless framework for Kubernetes. Here, let's get a cluster going. So the nice thing about Kubeless is it's similar to OpenFaaS and some of the others, but one of the nice things is that these are just native Kubernetes objects. You get a pod, you get a service, you can even define your function. They give you a custom resource, so you can define your function in a manifest and deploy it that way, or you can deploy it with the command line tool, which is what I'm going to do here. Let's create our namespace, and we're going to apply their manifest. Oops. Wait till this comes up. So here's what our code looks like for this. So they use Bottle, and it's pretty nice because their pod will come up, and then it just loads our request handler. So we can define this handler. We get an event and a context. So no matter the language, you get an event and a context. If it's like Go, you have to import their package, but for Python, we define it like this. In that event, we get all the information about the request. So the request itself, the payload, the host, all that kind of information. And then we also get the context, which is just information about the function, like amount of memory, the name, etc. So what we're going to do is, in our request, we're going to go into extensions and then request to get the actual request itself. And then we're going to grab the ID from this custom header that we're passing in. Imagine if you have like a microservice architecture and you want to trace when a request goes between microservices. You'd pass in, whether it's like Istio or Kong or any of your other service meshes, or Kuma or Kong mesh. They pass in these IDs to trace, and you can pass custom ones. So if applications key off a specific header, we can pass that as well. So what we're going to do is take that header and store that as ID, and then we're going to reach out to this endpoint called JSON placeholder, which just gives us some fake data back. It's a public endpoint, and we're going to store that, and we're going to create a dictionary from that response, and then we're just going to inject the ID from our request into that dictionary and return that back. So to do that, we're going to deploy this function. This is the name, so we're going to call it request. The runtime is Python 3.8. The handler is going to be the name of the file and then the function name. And then we're going to tell it which file we're coming from or we want to use, and then the dependencies. And since we're using requests here, since we're importing requests, we need to give that, just add that to our requirements.txt file so we can import that. Alright, let's wait for our container to come up. So it's going to do an init and build the initial container, and pull in our dependencies and everything, and then it's going to build our second container with for our function, so we can hit that endpoint. Now you can have ingress and create an HTTP trigger, and when you do that, it'll create an ingress for you, and it'll work with Nginx and Kong and Istio and I think Traffic and maybe another one. But right now I'm just going to port forward because that's easy enough for this demo. And here's what we're going to get. So we have user ID, title, and completed. And this is, again, just fake data from this endpoint. So we're going to wait for our container to spin up. All right, it's still pulling in Python. Seems to be taking its time this evening. I'll fast forward through this if I need to. So now that our pod's running, let's port forward. So like I said, we just get a service, and our service is named request, which is what we named our function. So now if we curl, we'll pipe that to JQ to make it look nicer, we get back our user ID, so all that information we got from JSON placeholder, and then that request ID that we injected in. So it's a pretty nice workflow. It's pretty simple, and you can do quite a bit with that. The other nice thing about it is we can use NATs to do asynchronous events. So, you know, we can just publish a message to a NAT subject, and our function will pick up that message based on a NATS trigger, and then be able to do something with the payload that's in that message. So it's a nice little system.